So welcome back, guys. Today I want to quickly run the experiments for the alternative B practicals. So those of you that probably didn't do your practical the first day, so these are the practicals you'll be doing on the 3rd of June 2024. So the practical involved three aspects: the lens, which is number 1, that's the light aspect, number 2 is electricity, and number 3 is mechanics. So the three practicals, I'll do that number 1 now. I'll show you an example. So I'll be using a question from the year 2014 to teach you how the practical should go. So from what we have here, the question says that, so for the number 1, WAEC said we should provide you a lens which is a convex lens, a lens holder. So this is the lens holder. So you place the convex lens in the lens holder. So you place it down. So they said we should provide you a ray box. So the question says that you are provided with illuminated objects, converging lens. So this is the converging lens, a screen. So this is a screen, meter rule. So this is the meter rule and other necessary material. So the question now says that measure and record the size A0 of the illuminated object. So this is the object, as you can see. This is the ray box. So come closer for them to see. So this cross now I've made it my object. So I am to record the size of that object, meaning that I'm going to record A0. So either from here, so this is my 0 now. So I want to record it, and that is like 3.4. So from what I just measured now, so my A0, so you record A0 equals 3.40 centimeter. So that's my A0. I've done that. So the next thing is that place the object O. That means the object now, the cross that I just showed you now. So I will off the light so that you will see. So focus the camera more on the experiment now. So place the object O and the screen S. So this is my screen. This is the object. So you are going to place them on opposite side of the lens S. So this is the lens. So you place the screen here and you place the objects here. That's what that part has said. Set the distance between the object and the lens U equals 30 centimeter. So it's telling me to take my meter rule now. Place this one at 0. So you place this at 30 centimeter. So can you see? Now this is the 30 centimeter mark. So you place this lens at 30 centimeters. So you place it at 30 centimeter mark, and that's what I've done. So the distance between my object now, which is this, and the lens is 30 centimeter mark. So now adjust the screen until a sharp image is formed. So now I will off the light so that you can see the image on the screen yourself. So you look at this screen. So if you look at the screen, you will see that I have a blurry image. Now, if you keep moving it to the back until a sharp image is seen, so just look at it. You now have a cross as my object. You can see that it's getting blurry now. So which parts am I going to see the sharp image? Let's check. It's getting blurry, so I want to stay around this region. So I think blurry, so it's sharp now. So the image is seen clearly now at that point. So if you check, so let's see, it said until a sharp image is seen, and we have seen that at a point on the screen. Measure and record the size A of the image. So what the same thing I did for the object, they said, what did I do? They said I should measure when U was 30.00 centimeter, and I've done that. They now said I should measure and record the size A of the image. So I want to know the size of the image, and that is what I'm going to do here now. So the same way I measured the other one, try to be careful not to push it over. So this is 0. My hand is shifting, so that's around 3.0. So that's exactly on 3.0. So my A is 3.00 centimeter. So I have my A0, which is 3.40. My A is 3.0 centimeter. So that's the first one. So the next thing says that evaluate M equals A over A0. So evaluate M is equal to A over A0. And that's my A is 3 over 3.40. So that's what I'm going to do now. So who has a calculator there? So divide A divided by A naught. That's 3 divided by 3.40. What do you have? 0.8823. So that's 0.8823 to 4 decimal places. Now M is not going to have units since this is in centimeter and this is also in centimeter, so they will cancel out. So the next thing is that they said I should look for M inverse. M inverse means that I should look for 1 over M, and I already know my M, so I'm going to say 1 over 0.8823. So what would that give me? 1.1334. So that is my M inverse. So that's done. They now said repeat the procedure for 4 other values of U. So let's do this now. Let's form our table. From our table, this is going to be constant. So for you write table of readings or table of experiments. So now to form my table, my A naught is equal to 3.40 centimeter. That's not going to change because you only measure this thing once, and we are not going to keep changing the object, so the object remains the same. So what am I going to do now? Since I've already known my A naught, then you put your serial number. Then number 1, you remember we first did U. For U is the object's distance. That's from this place to this place, and that's with the first one. So the unit of U is in centimeter. So for number 1, our U was 30.00 centimeter, Abby. So when U was 30.0, they said we should look for A naught. And what's the unit of A naught? That's the image height, object height, and that is also going to be centimeter. And what did we get for A? Was A naught we were looking for A. So what's the A? That's 3.00 centimeter. Then you do it again. They say you should now look for M. So that means your M is going to be A over A naught. And the unit will not, there will be no unit since centimeter cancel out centimeter. I hope you're following that. So we first place this guy at 30 centimeter. Then we measure the image. After we have seen a sharp object, we measure the image. Then we are now doing M is equal to A over A naught, which was what we did here. And we got 0.8823. So if you want to leave it in 4 decimal places, continue like that. Don't change it. So you have to be consistent. If you don't know how to do table, visit the previous video I've done. So you have to also look for M inverse. So for M inverse, we got 1.1334. So we are going to repeat this experiment again. So they said we should repeat it for 1 when it is 35. So we're going to do for 35. Don't forget, be consistent. Then we're going to do for 40. Which other one? So we're going to do for 45 and 50. 45 and 50 centimeters. So we have done for the first one. So if you didn't get the first one, let's get it right now. These are a table of experiments. So the first one gets for 30 centimeters. So for the second one now, let's do it. We're going to get for 35, meaning that when this one is at 0, so we'll place our lens at 35 centimeters. So it is now at 35. Then we'll try to move this until we see a sharp, clear image. So you can see the image now. The image is clear. So I can see my image clearly at this point. So now that is the point where I'm taking my, can you see? So now I want to measure the height. So when it was at 35 centimeters, so let's measure the height of this object. So that is, we are going to do that again. So that's going to be from 0 to, that's around 2.5. Don't want it to keep shaking because it will reduce the size. That's around 2.5. So what we have here is like 2.50 centimeters. So we'll do that again. So we'll do our A, that's 2.5 divided by 3.4. So let's do that again. So that's why this one has to be there, because it's the constant.
0.7353.
0.7353. So do 1 over this number. Now what do we have?
1.359.
1.3359. 0. So you make sure that it is still in 4 decimal places. It has to be consistent. So now we are done for that. What do we do now for 40? So we'll place this at 40 now. Then when it's at 40, we try to get a clear image as well. So avoid parallax error. So you can see the image is getting smaller, but it's now brighter at this level. So we can measure the height now. So let's check. So that's going to be, that's like 0 to 1.5. Can you see? So that's 0, that's 1.5. So yeah, you can see that there's a bit of trend here. What did you notice? 0.5 kind of different, or one difference here. So this was 2.5, 1.5, and this was 3.0, that's 0.51. So let's check. So what would that be? What did you get?
0.4412.
0.4412. Then 1 divided by this answer.
2.2665.
2.2665. So that's the next one. So the next one is we should do for, that's 45. So we'll place it at 45 now. Then we also check for a clearer image, blurry. So you keep moving until you see a very sharp image. So I think it's around this region now. So let's check the height now. In another question, they might ask you to calculate the distance from here to here. So it depends on the question you see. It might be from here to here. That means you want to know the image distance. But for this now, we have known the object height. So they now want us to calculate image height. So instead of knowing object distance and image distance, so it can come in any form. So but this one we are using object height and image height. So that's 0 to Jesus, except the first one. Let me quickly repeat that 40 and see, because I'm also getting 1.5 again. Oops. This 40 is around 1, it's even around 1.8 or thereabout. So it's not 1.5. Yes, it's around 1.8, but I'm not going to repeat that since I'm just using it to explain. So that's around 1.8 here. So let me change it back to 45. So try and make the screen should have been a heavy screen so that it will be stable. You should have placed something on this part, so maybe a heavy stone, so that when you are measuring it does not keep shaking. So let's check this time now. So it is at 45 now. So let's check when we'll see a clear image. I think it's seen here. So that's 0, shifting. This is 1.5. So for this one that we have here, this is actually the one that is this 1.8. So there must have been an error. So you can just check that out. So but not to waste your time, that's why I'm not going through it again. So let's check. So we'll now place it at 50 now. So at 50, then let's check. Blurry, clear. So now at 50, let's check. 0. That's almost like 1.1. That's like 1.1. So that's like 1.10. Then you do that. 1.10 divided by 3.4.
3235.
0.3235. So 4 decimal places. So what would this be? 1 divided by this answer.
3.0912.
So that's that. So we are done with all our values. So the question now says plot a graph of M inverse, that's this one. Plot a graph of M inverse on the vertical axis and U on the horizontal. So that means you go to your graph now. If you don't know how to draw graph, you can visit the previous video we have done. So you're going to have M inverse on the vertical and U on the horizontal. But don't forget, M inverse has no unit. That's why there will be no unit here. Then you put the unit of U here, that's centimeter. Then what do? Select your scales. So you select scale. There was a cheat or a trick I taught on how to select scale. Then after that, know the number of units. Know the number of units you are representing on the vertical and the horizontal axis. Then start counting. So you are plotting this against this. It's easier for this because you have 30, 35, 40, 45, 50. So you can just go on from 10, 20, 30, 40. So that might be. From what I thought, just take the highest value plus the lowest value. So you add them together. So you can take your highest is 30. So you can say 30 plus 50. Your highest is 50. So equals 80 divided by 10. So divided by 10. So that's 8. That means you can still make it 10. So you can go on to say 10, 20, 30, 40, 50, 60, and so on. So you can go on like that, it's okay. So you can have that as the range. Then for this one too, you take the highest value, so you plot that and you start plotting against. And you remember each box is going to represent 10, 10, 10, 10 units. So I'm not trying to teach you the graph again, just use the table based on what I taught in the previous video. Go and try to sketch your graph yourself. So that's the first experiment. The second experiment is on electricity and the third one is on mechanics. You are provided 2 meter rule in the third one and you're going to be provided 2 Richter stand. So I'm not trying to do that experiment now, but just quickly to explain that. So you take the 2 Richter stand, then depending on what the question, just always follow instructions. The question will let you know what to do. So you take the 2 Richter stand and you take your meter rule, you attach a thread here, then attach a mass on this thing. There's a question on that, you can go and check it in 2019. So when you attach the mass, then you start oscillating. So just follow the instruction. So for maybe 20 oscillation, 30 oscillation or thereabout. So that's what you're going to do. So if there is time, I will do that tomorrow and I will upload that. But go and practice this that I just said. So there's another question. This is 2014. So practice the one for 2019 and there's one for 2018. So practice those 3 questions. One of them might be your own question, and that is it. So don't forget to subscribe. We'll be doing the videos for the ones for NECO soon. So get ready for that as well. When you subscribe, you're going to get notification on all the videos we make and everything will go on fine. So make sure you subscribe, like and comment. If there's any question you want to know, maybe you still don't know how to draw graphs or there's any form of confusion, just let me know in the comment section and I'll see you in the next episode.